Today's lesson is how to transform exponential functions. So let's start with the parent graph. F of x is equal to 3x right here, and the base is 3, and so we know that there will be an asymptote on the x-axis because there would never be a 0. 3 to the anything is never 0. If you put a 0 in for x, then that would be 1, so we know that. So we know that the y-intercept is always 1 above the asymptote. That's an important trait for later. And then when I put in 1, that'll be 3 to the first. So when I go over to 1 right here, then that means that I will go up to the base a height of 3. And 2 would then be 9, but I don't believe I have that high up on my graph, so I will just sketch these 2 points. Basically, when I'm grading your graphs, I would look for those 3 key points. I would be looking for your asymptote, the point above your asymptote at this point it's the parent graph, so at 0, and then where the base is. So on the next problem over here, we have same base, so it's going to have the same shape. All that's going to happen is that's going to translate 2 units up. So that means that we would move our asymptote from the x-axis, we'll move it up 2 units right here. Asymptotes are always dotted because they're not actually part of the graph. They need to be there, but it's not part of the exponential function. And then we know that from there it should be shaped the same way. So my y-intercept will be 1 above the asymptote, and if I move 1 over, I will go up to the height of the base. So 1, 2, 3 right here. And so then we have a transformation that is a translation, excuse my writing, I'm not used to writing with this yet, translation 2 units up. So you can see that it is exactly the same shape, and my y-intercept is exactly the same distance that it was above the asymptote as it is in the original, and that 1 over, I went up 3 units here, and same thing here. From my asymptote, I went up 1, 2, 3 right there. On this problem that we have here, I already have the parent graph drawn on the left-hand side, and now we are going to take a look at what happens when we add inside the function. And so we're adding to the x, so this is going to be a move 2 units to the left. So let me grab my pen. My asymptote is not going to move from the original location because I'm sliding things to the left. So a horizontal line, you can't tell the difference. If it moves left or right, it's going to be still a horizontal line. So then we are going to move what normally would be a point right here, right? It's going to move 2 units to the left right there. Let me put that point right there. And then normally we would then from that point, it's easy just to go, okay, my base is 3, so over 1, I'm going to go up 1, 2, 3, put a point there, and draw in, whoops, I missed, just make the point really big when you miss. There's my graph translated, so this is a translation, 2 units left. For this page, we will be looking at reflections. So we want to pay attention to where the negative sign is. This one is on the outside of the function, so we're reflecting over the x-axis, so it'll look upside down. And this one, the negative, is inside the function, so it'll flip over the y-axis. And so it will look like it flipped from side to side. So let's write down those pieces of information first before we move forward. So we're going to do a reflection over the y-axis, nope, x-axis, oopsie. And this one is a reflection over the y-axis. So outside the function is x-axis and inside the function as over the y-axis. So if we're going to consider reflecting over the x-axis, and normally there's an asymptote on the x-axis, it's going to stay put right there on the x-axis. So here's our asymptote. And then normally we have one above the asymptote, we have a 1 unit up, and now we're going to reflect over the x-axis, so it's actually going to go 1 down. Use the asymptote as a mirror. So we have a point right here. Okay, now this one is a base 2 problem, and so when we normally move over 1, we're going to not go up 3 like the last couple of problems. We're going to go only up to 2, but we're going to reflect it over our asymptote 2 units. So it's going to be right there at 1, -2. And then we can draw our graph like so. Okay, so that's reflected over the x-axis. Now if I'm going to reflect over the y-axis, your asymptote is going to be right here, and then if you reflect it over the y-axis, then the piece that was here will move to this side and this one, so it'll appear like it didn't move at all. So just draw it. Okay, and then the next point we look at is the 0, 1, and we're reflecting over the y-axis, and it's on the y-axis, so we don't move it at all. Stays right there. And now this one, this is where it's going to look, the only place it's going to look different. Normally we move up over 1, go up to the base, which is a height of 2, but we're going to reflect it over the y-axis using that as our mirror, so it's going to come over here to -1, 2. And you might think, well, then that looks like a decay problem, and it actually is, because this could have been rewritten as 1/2 to the x, because anything to the negative power would be a reciprocal. For this page, we'll be looking at base E graphs and with combinations of transformations. So this first problem, we have base E, which remember is like 2 3/4. It's 2.72-ish. And so we have base E, and then we're going to move 2 units to the right, and we're going to translate it 3 units up. So let's write that down first before we start graphing it. So we have the transformation is a translation two units right and 3 units up. Okay, so we need to figure out where the asymptote is, because it's easier to graph the rest of it if we know where the asymptote is. So first, if we're thinking the asymptote would normally be on the x-axis, and we're going to shift it 2 units to the right. It doesn't look like it moves anywhere, but as soon as I move it up 3, my asymptote's now at y is equal to 3. So I'm going to draw that in. Okay, and then because of the -2, normally we would be 1 above the asymptote where it would have been up 1 unit, so then I would have been here, and then we're going to move it 2 units to the right. So that's my new spot right there. And then normally we would have had over 1, we would have gone up almost 3 units here. We're going to move that 2 units to the right and 3 units up, so 1, 2, 3, so right about there, and just to double check, it should be just a little bit less than 3 units above your asymptote. So 1, 2, whoops, I'm just a tad bit high. So bring it down just a little bit. So 1, 2, right there. And go ahead and draw it in. Don't forget your arrows on the ends of your graph to show that it goes on forever. The domain on exponentials is all real numbers. So arrows there, but we definitely have a range domain, a range restriction. We aren't anywhere below that y is equal to 3. So domain goes forever this way, goes forever this way, but we are never anywhere below that asymptote. Okay, so now let's look at this problem here. We have base e again. We have a reflection over now that's inside the function, so it's over the y-axis, and then we're going to translate down 4 units. So let's write that down. So we have the transformation. Just realized that I spelled the word transformation wrong over here. Oops, it won't let me fix it. Oh well. Is a reflection over the y-axis and translate 4 units down. Okay, so let's get started on that, excuse me. So the asymptote would have been here normally. We reflected over the y-axis, doesn't seem to change, but as soon as I move it down 4 units, that I see a change. So I need to draw my asymptote 4 units below the x-axis. Okay, and now let's figure out where the rest of the points go. It normally would have been here at 1, and then we're reflecting over the y-axis. It's still on the y-axis, so I'm still just going to move it down 1 unit. And then the -4 is normally we would have been over 1 up almost 3, but we're going to move that straight down 4 units. So that would be, or you could think of it as being 3 above your asymptote. So that's 1, 2, almost 3 is right there. There's your point right there. If you were to count from the other direction, here's almost 3. It would have been 1, 2, 3, 4. So, and go ahead and draw that. Okay, I hope that gets you on your way to your new assignment that you'll find on Big Ideas, and let me know if you have troubles. Bye.